Everyone, can everyone hear me?
Yes.
Perfect. I'm joined by my esteemed colleague, Dean Jones, who's the branch general manager as well. Let me just bring up my screen. Screen three. Can you guys see my screen?
Yes.
Perfect. Good evening, everyone. My name is Haris Murtaza from Alsco. I'll do a formal introduction on the next slide. Just letting everyone know if I look tired, it's because I'm dialing in from Sydney. It's almost 8 o'clock here. Haven't had dinner, and I've got a very young baby who doesn't sleep. So everything on top of each other right now. Yeah, so Alsco Uniforms, I'll pass it over to Dean to talk through a little bit about Alsco and introduce himself, and then we'll get into the challenge statement.
Hi everyone, my name's Dean Jones. I'm the branch general manager from Alsco Uniforms in Singapore. We're a worldwide uniform rental company. The basic premise of our business is that we provide garments to our customer base, and as part of that rental, on a rental basis, and as part of that rental, we launder them. Um, we're in 15 countries worldwide with about 200 branches and around 200,000 customers around the world. So basically, what we're trying to do as an organization is to reduce our carbon footprint and other measurements that are driving towards sustainability. And primarily, what that is, or our primary emissions are based around either transport, which we won't get into today, or the processing of those launderable items. And so Harris looks after sustainability in the region, and I've asked him to assist in designing some potential projects that we can offer. Thank you, Harris.
Perfect, thank you, Dean. Yeah, so Energy Utilities Manager for Alsco. I've previously been based in New Zealand and now based in Australia, so do work for Alsco Uniforms across the region. Just a little bit about our challenge statement. So we've got two to go through. The first one is to recover and reuse waste heat from our industrial gas dryers. So as Dean said, we're a commercial laundry. We wash, dry, and iron our textiles. So we've got big industrial grade dryers, 200 kg dryers that have latent heat of about 150 to 180 degrees go out from the exhaust at any given time. And then we've got cool inlet air coming in from the atmosphere, which is heated either using steam or it's heated using a direct gas burner. So primarily we've got gas dryers, but in some instances we've also got steam dryers in our facilities. So we've got hot air being vented out, and there's no heat recovery or energy recovery on that, and then we're pulling in air and then heating that up further. So there's a potential to do some heat recovery. We've tried to do this in the past. Unfortunately, lint has been a massive issue. So a lot of the lint going out, it's been caught up in the heat recovery units, and it's posed a fire risk. So we need to do a study where we can get rid of the lint problem, and therefore we've listed some technical requirements. So we want to do heat recovery on 150 to 180 degrees and heat up the inlet air coming in. It should be self-cleaning and have lint removal features. It should ensure that there's no fire hazard. It should recover heat for reuse in air preheating. Must avoid any back pressure, so you can't take out too much heat. If you go below the dew point, then you'll have back pressure, which will affect the efficiency of the dryer. So even though we're doing heat recovery, we can then negatively affect the running of the dryers, meaning that they'll start using more gas. So that will lead to adverse outcomes. We've got to make sure that any heat recovery material used should be non-flammable, um, corrosion resistant, and capable of continuous high temperature operation and recovery. And it should comply with relevant industry fire safety standards. If we can do a proof of concept, a POC, we've got we've got more than 80 dryers in the region. So there's a massive opportunity here to do heat recovery on all of them, even if we can do one proof of concept. So um, the emissions reductions across all of Alsco is about 25% reduction in our greenhouse gas emissions. So this photo I took online, but we did about 10 years ago. Alsco in America did try to heat recovery using a similar system like this. However, we had lint build up from the residue of the textiles, and it started smoldering, and we nearly had a fire. So we have tried in the past. It's just about finding a solution that mitigates any fire hazards or anything as such. So that's our first problem statement. Did anyone have any questions or any comments or anything they would like to clarify or anything that you would like to add, Dean?
I know that's good. Thanks, Harris. I think you've explained it well.
Cool. I think those on the floor, if you have questions, please start typing to the chat box. And Harris, let's I think move on to the next one.
Perfect. Our next one is the development of solar integrated heat pumps for commercial laundries. So we started looking at solar battery storage and heat pumps separately, but we want to bring it all together. So like, for example, Singapore's got a massive 320 kilowatt solar energy system. Some of our sites don't have any export allowed. So there's export limitations where we can't export outside work hours. And what we want to do is once we're not working on site, we're not a 24-hour operation, so we're only one shift. So after work hours, if there's sunshine still left, we want to be able to store that power in a battery, and then closer to the middle of the night or at cheaper electricity times, use the battery plus cheap energy from the electricity grid to run a heat pump and generate and store hot water. Therefore, you have thermal storage as well. So we want to generate and store hot water at 55 degrees. We want to integrate with existing systems, allow load shifting capabilities. And I've got a little bit of a drawing here just to show it a little bit. So we've already got solar PV, and we're also trialing batteries at certain places like different facilities. And we're going to do a trial of our first heat pump where we use our wastewater as a heat sink. It's just about we're looking at a design and a control to bring it all together in one facility where we can say this control system will bring in our solar and have the smarts to store the solar energy into the battery after hours or at times of excess solar production. And then during the middle of the night, 2, 3 a.m., when there's a low energy cost in the grid and the battery is charged, run the heat pump, discharge the wastewater, do heat recovery, run the high temperature heat pump, generate and store hot water. So it's ready for the next day. This is, again, we're trying to bring this together, have someone integrate this technology. There's massive potential here for load shifting and for using technology at times of low demand in the grid. So do anyone have any questions? Or Dean, did you want to add anything to that?
No, again, you've got it covered.
Yeah, sorry about my voice. I've lost my, I've had a pretty tough week.
Cool. Thanks, Harris, for the extra hours, sacrifice for this session. Thank you very much. And to the floor, if you folks have questions, please shoot on the chat box. And I think meanwhile, Harris, Dean, just want to check, I think besides what was published in terms of the challenge statement requirements on the site, are there any key consideration or anything that you would like to highlight out of those requirements for the participants to take extra note of?
Yeah, so we know that, from my opinion, when it comes to the integration of solar, battery, heat pump, we're looking at something that a technology that, or a control, or a software, or a PLC that brings it all together and brings all the smarts. We know that we can procure solar ourselves, we can procure battery ourselves, we can procure the heat pump. It's just about something that makes it work all together and does some um, balancing of the energies on site. That's for this one. And for the heat recovery, again, we're looking at a proof of concept to get rid of the lint issue, because we know there are industries overseas that do heat recovery on industrial dryers. It's just that we've got textile lint as a build-up problem, which can lead to fire, that we want to get rid of. So if anyone has any experience with that, either overseas or in Singapore, we'd love to hear from you.
Got it. Sounds good. Okay, I think we don't have any further question. I think besides that, for those on the floor, if you have any further question, any technical question, do send it over to info@parang.co, and I think we will definitely pass that over to Dean and Harris to attempt to clarify.